All right, welcome back to Teaching Elixir. This time we will be covering modules. And the idea here is that I am teaching my friend, who's an experienced developer, but not super experienced with Elixir, about Elixir using Elixir School. And just, if this episode is a little bit weird, we absolutely did not record this entire episode and publish it and then realize it was entirely unwatchable because the entire video was black. That is not a thing that happened, and if you managed to see that version, it never happened, okay? But yeah, so if it seems like we've seen this material before, that's because we have. All right. Modules. Do you know about modules?
Yep. They're the best.
Yeah. My wife just came in and waved at us.
Oh.
Yeah, perfect. We'll roll with it. All right. So modules is a way of organizing code in Elixir. And sometimes when you're coming from an OOP background, it's tempting to try to map that to classes. And I don't think you necessarily should. So if you have a big old static class, for example, with just static methods, and it's basically not ever instantiated as an object, then you basically have a module. But then you are also not doing OOP necessarily. But for the typical use case, a module is a way to organize concepts. It doesn't have all that much sort of runtime impact, while some people coming from OOP are like, okay, so modules aren't classes, but gen servers, those are pretty much like classes, right? And that's also the wrong path to take, I think, because gen servers are about runtime behavior. While I don't know what classes exactly do, what would you say is the purpose of a class?
Is to group behavior and data into a nicely manageable blob.
Yeah, fair.
And then you can instantiate the class and get an object. And maybe if you squint enough, an object could be a gen server, but probably not.
Yeah, I mean, it could be, but it's also... so what you get with a gen server is data, code, so data and behavior, and the concurrency.
Yeah.
And you get message passing, which adds more factors in there. So I think if you're trying to do OOP style stuff with gen servers, you are probably trying to map the wrong thing to another thing. But modules don't have data. They might have structs, which we'll get into. But they are an organizational tool, essentially. There's some meta programming where it also matters, and it's like no function can live outside a module in Elixir and Erlang. So there's a lot of modules around.
Yeah.
Okay. So in the introduction here, we know from experience it's unruly to have all of our functions in the same file and scope. In this lesson, we're going to cover how to group functions and define a specialized map known as a struct in order to organize our code more efficiently. Sounds good.
Yep.
So modules allow us to organize functions into a namespace. In addition to grouping functions, they allow us to define named and private functions, which covered in the functions lesson. Let's look at a basic example. So you call this example module has a public function called greeting, and if you pass it a name, it will return that with a hello. So example greeting, Sean, hello Sean. Fair
Good
enough.
stuff.
It's possible to nest modules in Elixir, allowing you to further namespace your functionality. So this typically is used as mapping to a file structure. There is a sort of standard file structure that you'll see in Elixir, but it doesn't have to. There's no true mapping between those two, aside from, I guess Phoenix does use some of the sort of default paths to figure out where things should be. You can override it, but sort of it has some implicit ideas about where it should find templates and stuff, which saves some time. But really, you can have multiple modules in a single file. It's atypical, but it's used for some things. And you can have modules inside modules. So, but this case, they just have 2 levels in the module name. This is also what you would get if you inside the example module. If you would define a greetings module inside example module, that would give you an example.greetings module. So.
Cool.
Yeah.
And modules can have attributes.
Yeah, so that's the next part. Module attributes are most commonly used as constants in Elixir. Let's look at a simple example. They are also sometimes used in sort of metaprogramming and such. But yeah, they are evaluated at compile time. So, and then any use of that module attribute in code, as far as I know, has this actual literal inline. So, very constant.
Yeah, very constant. And you put an at in front of it to give it its own namespace or something?
That is the marker for this is a module attribute, because you can write arbitrary code inside a module.
Yeah.
Because you can do something like do a for loop and then define functions in it.
Yep.
And then you're doing some metaprogramming fanciness and generating functions based off of something.
Wow.
So there are a few reserved ones, reserved attributes. Module doc, and behavior. And those are... So module doc, typically at the top of every module you want a piece of documentation.
Yep.
That's used to auto-generate documentation and also can be used for doc tests.
Nice.
I think that goes straight in the module doc. Yeah, it should. And then doc is for functions and macros to have their own documentation. So you just put it in right above the... So that would be... Typically you'd use these here doc, I guess this is.
Yeah.
Foo, bar, baz.
Yep. Looks like almost like the syntax in Python.
Yeah, very similar.
Yeah.
And behavior, that's when you want to use an OTP or user-defined behavior, which I don't think we'll get into now. Structs. Structs are special maps with a defined set of keys and default values. A struct must be defined within a module which it takes its name from. It is common for a struct to be the only thing defined within a module. To define a struct, we use def struct along with a keyword list of fields and default values. So here we have an example, which returns the module. But here it's generating a struct with a name, and by default that name will be Sean, and the roles, which by default will be nothing, an empty list.
Yeah.
And
do you have to have default values on all keys?
No, I think you can just shove the keys in there. And I guess they will be nil by default unless you add. So there's a module attribute where you can tell it. No, not like that though.
How?
So the keys are atoms.
Oh.
But yeah, maybe you can't do it that way. I've seen something akin to this, but
Oh well.
I don't remember. I usually had some kind of default value, even if it's nil. All right. But creating some structs. So here we see it return the actual struct instance. And so this is an instance of a struct. And if we instead instantiate it with another name, it has another name. And if instantiated with other roles, it has other roles. And once we have it going further down, we can update it just like we could a map. So this is the shorthand for updating an existing key in a map.
Yep.
And you can match it as if it's a map. Want to know why?
Because it is a map?
Yeah, exactly. So we could say, oh, we require this to be a struct of type example.user. But we don't have to.
And then we don't
because matching on a map is always it just checks for the things you are matching against, so it ignores any keys that you aren't currently matching for.
Exactly.
So I believe we can do, is this the way I do that? No, that's no good. Let's see. I would probably need to do this, I think. Yeah.
Yep.
While if I use a module name you've never heard of, that would not match.
Cool.
Because the way it is turned into a struct is that there is an underscore underscore struct underscore underscore key inside the map, which turns it into a struct. So it's a thin layer on top of maps. And a bunch of conveniences for for syntactically prettier matching and stuff. So.
Nice.
As of Elixir 1.8, structs include custom introspection. To understand what this means and how we are to use it, let us inspect our Jean capture. So this is about the fact that we can tell with the derive module attribute, we can actually tell it to not show all keys in an inspect during an inspect. And actually the inspect also treats structs a little bit differently than maps, because it will not include the struct key, but it will include the struct name in the output. So it already does some special stuff for structs.
Yep.
But you can control. So if you have sensitive information that you never want accidentally logged, for example, in a struct, or sort of internals in a struct that you don't want to expose, you could use this to limit the amount of limit how much you're showing by default. People can still get to it, but you wouldn't show it by default.
That's a good start.
So now it wouldn't show roles.
Cool.
Composition. Are we sort of clear on what a struct is for now?
Yep.
Cool.
Nothing strange in there.
Yeah. So basically just predefined maps, and it's a very useful thing to have. Gives a lot of... just makes it a lot easier to reason about what you're dealing with sometimes. Yeah. So they're talking about composition here, and essentially they're getting into how do you use other modules in your modules. And alias is the first step there. Very frequently used, and it sort of does nothing, because what it does is you can see this example lines 5 to 9.
Yeah.
So you alias sayings.greetings here, and then you can call greetings instead of sayings.greetings.
Cool. What happens if you have sayings.greetings and bob.greetings? And can you alias both?
I believe you would get either a warning and that the first one gets shadowed, or you would get an error. I don't actually remember.
Cool. Can you alias? If I think greetings is a way too long name, and I want to alias it as very good. Yeah.
Grr.
Grr.
I
Very
believe
good
that's
way
the
of reading.
syntax. There is a syntax for it at least.
Yeah.
So, if there's a conflict between two aliases, or we just wish to alias to a different name entirely, we can use the as option right here. Okay, it's even possible to alias multiple modules at once. So if they're sayings.greetings and sayings.farewells, we can alias them at the same time with this syntax.
Yep.
And then import. This one is I've seen a lot of people use this early on in Elixir, and it seems like it was maybe a bit overused.
Mm-hmm.
I'm not very partial to using imports a lot, because it removes a little bit of the path for following where did this function come from.
Yeah.
But essentially you're saying, take all the functions in that module, add them to this module.
Okay.
Or make them available in this module. But I think it actually adds them. I don't remember right off the top of my head, but I think that's actually how it goes. So there we don't have last. Now we've imported list, and now we have last.
Yep.
And you can filter on which ones you actually want to import. And for macros, you actually have to import. You can't alias a module and use the macros in it. You need to either require or import, depending a little bit on what it's doing, that module.
Interesting.
So you need to require logger, but you can import ecto.query.
Yeah.
And usually with ecto.query, I don't want the entire API of it. So usually I do only from or only from and where. And then you use this syntax where you import list only last, and then you don't have first. And if you import list only last, you do have last.
Yep.
And the one is just the arity of the function. So if there's multiple different variants of last, you're only importing the ones you state. You can also use an except instead of only. So you can exclude something that collides with something you've defined already.
Yeah. If I want to import many arities of the same function, can I just...
I think you need to list them.
Okay. So
or you could use
write.
except.
Yeah, that's true.
Or just use import. But
and the keys aren't unique in this list, right?
no, they're not. It's a keyword list, which is just a list of tuples. So
Yeah,
it
got
duplicates.
it. So I can write last as many times as I want.
Yeah, probably.
Cool.
Until memory runs out.
Yep.
If we import everything except last and try the same function as before, yeah, that also fails. In addition to the name arity pairs, there are two special atoms, functions and macros, which import only functions and macros respectively.
Sweet.
Require. We could use require to tell Elixir you're going to use macros from another module. The slight difference with import is that it allows using macros, but not functions from the specified module. Yeah, right, that's the diff. So this is what you do with logging. So you require logger before you use it.
Yeah. Yeah,
We don't have a module called super macros.
that's a shame, really.
Uh, so, and then there's use, and you will see use used quite frequently, especially in Phoenix, which has quite a few macros to make things more convenient. You will see a fair bit of use. And when you use a module, you are saying we want to call the using callback defined in that module, and the using and the result of that callback or macro becomes part of our module. So it allows another module to add things to your current module. So this here's an example. So def module hello. This, and here you def a macro called underscore underscore using underscore underscore.
Yep.
And then we quote do def hello name do hi name. So we add this hello function we've been seeing a lot of.
It's a good function.
And if we now want that hello function in another module, we can use hello. So in this example module, for example. And then we can call that. So this is, at this point, this is a little bit pointless. But whenever you want to hide a lot of implementation details, sometimes using can be good. But you can also do things where you pass some information to the use macro, or the use macro will actually trigger quite a lot of behavior where it sort of introspects the current module and does a bunch of smart things to generate necessary functionality. So it's a very powerful meta programming tool.
Nice.
Here we can see that use invoked the using callback on hello, which in turn added the resulting code to our module. Now that we've demonstrated a basic example, let's update our code to look at how using supports options. Yeah, so we're getting that. Now they're actually using the opts argument.
Yep.
So it allows us to pass a greeting key. And then here in the module, we can use hello and pass a greeting hola. And that will then mean that we go hola, Sean, instead.
Nice.
So yeah, as they're saying there, these are simple examples.
Yeah.
And yeah, one example here they're mentioning is EX unit, which is the testing framework for Elixir, the default one. Has an option for async true, where if your tests can be run entirely sort of independently from one another or asynchronously to other tests, you can pass the true. Otherwise, you can pass the false. That can really affect how fast your tests run.
Nice. Fast tests are good tests.
Yeah. And yeah, I think we'll see if we get as far as Elixir School's metaprogramming part. But that's where more of this stuff is unpacked. So that's essentially it about modules. I think a lot of the more common uses in modules we actually covered in the functions part, where def and defp live.
Yeah.
But yeah, modules, they're great. It's a nice way to organize things. So let's see if we can cover some Beam basics here. But my understanding of both Erlang and Elixir is every function lives in a module. If you have just generated an anonymous function, it usually lives in some kind of quickly generated under the hood anonymous module, which can be a bit spooky. But any beam process is a function, and every function lives in a module. So and every function call has arguments, even if it's an empty list. So you'll often see what's called an MFA in Erlang and Elixir, which is a module function arguments tuple. So they're often passed as a tuple when you want to reference, like, this is a call I want to make, or I want to tell something to make later. That's a common way of referencing that. So you will see those MFAs around. And Erlang processes, these nice cheap processes the scheduler deals in, those are always a function call. And that means they're always associated with a module. And they always have a bunch of arguments. And this was how you build modules. So now we've covered that. Maybe I don't think we've covered processes, so I guess we'll get there.
I hope so.
All right, that's it for now. Thanks for watching.